My dear students, today my topic is pumping lemma. The pumping lemma is used to prove that the language is not regular, and also it is used to prove that the context free language is also not a context free language. In two scenario, this pumping lemma is going to used. First, I am going to discuss about the pumping lemma for regular languages. So I am going to give a regular language, so that is not. It is going to prove that the language is not regular. For any regular language L, there exists an integer n such that for all x belongs to L, the language L, with modulus of x is greater than or equal to n. I am going to choose a value n, is any value. So what the value will be? That is modulus of x. X is nothing but our language. So the modulus of x, the length of the string in the language x is greater than or equal to n. So the string is, the language is greater than or equal to n. There exists, the x will be split into three forms: u, v, w. U, v, w. So that is also belongs to sigma star. That is also under the language. Okay, such that x is equal to u, v, w, and so there are three conditions. Modulus of uv, so that the string is split into three. The modulus of u is always less than or equal to n, and the middle part v is greater than or equal to 1. Then I am going to change the format uvw by increasing v by I, power of I. So I is greater than or equal to 0, uv power iw, which is also belongs to. So I am going to pumping the middle value any number of times, that is also belongs to the particular language. So this is a simple term. This means that if a string v is pumped, that is v is inserted any number of times, the resulting string still remains belongs to L. So this is the pumping lemma, prove that the language is belongs to regular or not. The language is belongs to regular or not. Pumping lemma is used to prove the irregularity of the language. The language is regular, it always satisfies the pumping lemma. So the language is regular means that should satisfying the pumping lemma. There exists at least one string made from pumping lemma which is not L, which is not belongs to L, then L is surely not regular. The opposite of may not always true. What I am saying here, if there exists at least one string made from the pumping lemma is not irregular. So we are using the pumping lemma to generate new language. The language is not in L. That L is not surely regular language. The opposite are not always true. Okay, that is, pumping lemma is prove a language is regular, so that may not be a regular language. Okay, that is the opposite meaning of that one. That is not so true. If the pumping lemma holds, it does not mean the language is not regular. Okay, yes, the pumping lemma holds, the language is regular. It may not be irregular. So both things are there. Okay. Here I have an example. Prove that L equal to 0 power n, 1 power L is 0 power n, 1 power n is greater than or equal to 0 is not a regular language. So what is my language? I have any number of zeros followed by any number of ones. This n is common for both zeros and ones. Number of zeros is same as that of the number of ones. So that is not regular. So basically we can take the contradiction of the language. So I can take it is a regular language. So I can take by means of contradiction 0 power n, 1 power n is a regular language. So now I am going to apply the values 1, 2, 3, 4 for the language L. That is, suppose it is 1 means 0 power 0, 1. 2 means 0, 0, 1. 3 means 3 zeros followed by triple ones. 4 means 4 0 followed by 1. Okay, let's x belongs to L. The modulus of n is greater than or equal to 1. So this is a rule. Okay, I am going to took n value, that is the modulus of x is greater than or equal to n. Suppose I am going to choose the first language 0, 1. The length of the thing is 2 for 0, 1. I am going to choose x as a 0, 1. So the length of this particular x is 2. Okay, so this is 2. So how my n will be? It is equal to n or less than, greater than n. Okay, yes. So x is always greater than or equal to n. So my n may be 1 or 2, not 3. 1 or 2, not 3. Modulus x is always greater than or equal to n. Okay, I can choose the value 1 or 2 for n. Okay, this n is not 0 power n, 1 power n. This is the pumping lemma rule n. Okay, this n is not here. Okay, this is n. Pumping lemma, there exists UV W such that will hold 1, 2, 3 rules. So already we brief about the 1, 2, 3 rules. So that will hold. So what is the first rule? So here 0 power x is equal to 0 power n, 1 power n, UVW with u modulus of u is less than or equal to n. This is the first rule. Then second rule, modulus of u is greater than 1. So I am going to split this zeros. 0 as the 3 part, that is A, B, C. So I split into 3 parts. So u has the value of 0 power A, V has the value of 0 power B, and W has the value of 0 power C, then 1 power n. So I am going to split anyway, any number of ways. Okay, again the W may be built at somewhere else. Okay, that is not a problem at all. So we should keep three parts of the x. Okay, whatever it may be. Here they are going to choose total string. So 0 power n in this n part is split into A, B, C. Then they keep the n 1 power n part is as it is. So what they did? So u equal to 0 power A, it is one part. V equal to 0 power B, that is one part. W equal to 0 power C and 1 power n. Here A plus B plus C equal to n. Here, so the total of 0 power A, 0 power B, 0 power C equal to n. The A value, A plus B plus C equal to n. So here modulus of UV. So modulus of UV is what? So A and B. So A plus B is less than or equal to n. This is definitely. C will be the another part, so that A plus B always less than or equal to n. Then B is greater than 1. Definitely B is greater, at least B value will be 1. At least B value will be 1. Okay, yes. Okay, so that is also satisfied. Okay, then C is greater than or equal to 0. C is greater than or equal to 0. If is so C is equal to 0 means what will happen? C is equal to 0 means, so the x value will be changed now. So 0 power A 0 power b and 1 power n. Basically, a plus b plus c equal to n, not a plus b alone equal to n. So, suppose if you are giving this part will be 0, it is not satisfying the condition. Okay. Yes. Listen here. Suppose what is the third rule? U v power 0 w. U v power 0 w. So here, so I am going to substitute 0 to the middle part. Okay, b. So this is the third rule. This is not satisfied by this condition by the language. U v power 0 w equal to, so suppose this 0 means only u and w, that is equal to a power c b 0 power a 0 power c 1 power n. So 0, how many zeros are here? There are 0 power a plus c. So a plus c is not equal to n. So we have to think of the middle part. So middle part will be there. Then only it is going to same as that of the n. So that here the b will not be added here. So that it is not supported to the Pumbing lemma. So what is this? So nothing is there. So the total regular language is split into 3. Okay. The middle part is going to pump any number of times. So that is also satisfying the L. So this way we have to prove that a regular language is not a regular one by using pumping lemma. For example, here I am going to choose x equal to 4 zeros followed by 4 ones, n equal to 4. I can choose x is equal to uvw. The first two values taken as a u, then second 2 zeros taken as v, and the last 4 ones taken as a w. Here modulus of uv is less than or equal to n. Modulus of uv is less than or equal to n. Yes. So n is equal to 4. I am going to choose n equal to 4 some value. So modulus of uv is less than or equal to 4. Okay. Yes. So this is n. This is a pumping lemma n. So I am going to substitute the same value to that. 4 zeros followed by 4 ones. Modulus of uv is less than or equal to n means yes, 4 equal to 1, it is a regular. So first condition is okay, it is regular. Then modulus of uv v alone is greater or equal to 1, it is 2. 2 is greater than 1, it is also regular. But uv whole power I w belongs to L. So now I am going to check I equal to 2. I am going to put I equal to 2 means, so the v, there is no changes in the u. I am going to put double zeros. Then v going to put in 2 times. So already it is 2 times. So now it is going to pumped by another 2 times, that is 4 zeros. Then followed by w 4 ones. Here this is 0 power 6, again 1 is 1 power 4. It is not belongs to L, a power n, b power n. So that I can set L equal to a power n and b power n. It is not a regular language. So by this way we can prove that a regular language is not regular by using pumping lemma. Okay, understand? Yes. The same way it is also used to prove that pumping lemma, the context free language is not under the category of CFL. Pumping lemma or CFL states that for any context free language L, it is possible to find 2 substrings that can be pumped any number of times and still it will be the same language. Okay, It's like as previous one. It is also proved that the context-free language split into 5 subdivisions. In this, 2 substrings are pumped any number of times, that is second and fourth. For example, you can take it as u, v, x, y. Here v will be pumped any number of times, x is also going to pump any number of times. It is also in the same language. Yes. So this should be satisfied. Then only it is a context-free language. Okay. So pumping lemma is used to, it is a tool used to prove that the language is not context-free language. Okay. So both is going to use. The language is not regular. The language is not context-free language. So pumping lemma is used to prove that the language is not regular and context-free language is not. The language is not also a context-free language. Okay. Because if any one string does not satisfy this condition, then it is not a context-free. Okay. Yes. So what is the rules behind this one? So L is the CFL. Then there exists an integer. You can assume that any integer value such that for all x belongs to L with modulus of x is greater than or equal to n, as like as the regular language. There exists in context-free language, the total language is split into 4 things: u, v, x, y. Okay. It is also belongs to sigma star, such that x is equal to u, v, w, x, y, and as like as previous one, here they are going to use 3 terms of u, v, w, x, y, x, y. Modulus of v, w, x less than or equal to n. Modulus, the length of the parts, there are 3 parts, u, w, x, that should be less than or equal to n. Modulus of Vx is greater than 1. Modulus of Vx is greater than 1. For all I is greater than or equal to 0, u v power I, that is second term, w x power I, that is the fourth term, then y. This is also belongs to L. I am going to split the language into 4. Then I am going to pumping the second position and the fourth position in any number of times. That is also belongs to the context-free language. Now I go for an example. So prove the language 0 power n, 1 power n, 2 power n, n is greater than or equal to 0 is not context free. Is not context free. So assume by contradiction L is a context free language. Then we are going to apply. It is going to prove it is not a context free language. So I take this language, take a contradiction of that one, then I am going to prove it. Okay. Yes. So I assume that L is a context free language. Let x belongs to L and modulus of x not equal to, no, modulus of x is greater than or equal to n, not less than n. So by pumping lemma, there exists u, v, w, x, y, z such that 1, 2, 3 must be held. There are 3 rules that should be held by this one. Okay. So we can discuss one by one. Okay. If 1 and 2 are held, then x equal to 0 power n, 1 power n, 2 power n, which is equal to UVWX. Here we can choose any value of n. So modulus of VWX is less than or equal to 1. Modulus of Vx is greater than or equal to 1. For first one, tell us VWX does not contain 0 and 2. VWX does not contain both 0 and 2. Suppose the u may take 0 value. U may take 0 value. So that it's not going to taken by the VWX. Okay. Thus either VWX has no zeros or VWX has no 2's. There may be a chance because the u going to take 0 and y going to take 2. So there may be a chance of not having these zeros and 2's. Okay. VWX has no zeros by 2. Vx contain 1 or 2. Vx contain a 1 or a 2. This may be a chance. Okay. V has 1 values or x has 2 values. So Vx has 1 or 2 values. There will be a chance. Okay. Thus UWY has n zeros and UWY either has less than n number of ones or less than n number of twos. So the way we are going to apply it, we can have some value changes. Okay, so you must have 0. VWX may not have 0 or 2. Okay. Yes. Okay, then come to the third one. So we are going to pump the middle value, second and fourth terms in any number of times. Suppose suppose you are going to apply equal number of zeros, equal number of ones, equal number of twos. Okay, gives us a contradiction. Okay. In the case where VWX has no twos. Suppose we are going to use the values to that, we are not having twos to that. So is similar and also gives us a contradiction, so that it is not a context free language. What it is, we are going to apply 0 values to Vx0, x power 0. So we have only UWY. So it may not contain equal number of zeros, equal number of ones, equal number of twos. You can varying the value V and X any number of times. That is not also belongs to L. So that the language is not a context free language. So that pumping lemma is used to prove that the language is not regular and also the language is not context free language. So the language which is satisfying the pumping lemma is also, there is a chance of it is not belonging to the regular or context free language. Thank you students. Thank you for patient listening. So we will discuss some other topic in the next class. Thank you.